Okay, this is Algebra 1-2, absolute value graphing transformations. It's going to take 3 different videos. Sorry that I ran out of space on the last one. I wanted to show you what happened on those. When we had a -1 in the absolute value within the brackets of the absolute value, the whole graph shifted to the right one. That's what you should have gotten as you finished up that table when we ran out of time together. So it shifts over to the right one. Then on the previous one, I had you do it on your own. This one, with the 2 on the outside, it caused it to move up 2. This one with the -1 on the outside, it moved down 1. So when the value's on the outside, that's the shift. Now, value on the inside, we had a -1. It shifts to the right one, over to +1. And here we have a +2, and we get a straight line. When you get a straight line and you're graphing an absolute value, I suggest that you continue to put in a few more points until you have a good idea of how to find the vertex, which is the corner. I put in -3 here, and it works. I end up turning that corner, and I get the V shape that I know should be common for an absolute value graph. So there we go. And I see that the shift has been with a -2 in there, with a +2 in there, it shifts to the left 2, to that -2 position. So you might start to see a pattern here with graphs, and that's when we start to graph by transformations. We will use this as a warm-up for class, so go ahead and skip that. But let's go to this next graph. What we have noticed is when the number is outside the absolute, it's pushing it up or down. If you turn back to the pages, you'll notice that a negative goes down, so it goes down to -3. Now, what we're doing is we're just moving that parent graph that was right here down to -3. But in addition to that, we see that we have a change of slope. That A value, remember, made it real wide or skinny. So we go up 1 and over 2 on our slope there. This causes this graph to be real wide down here at -3. So our vertex, the corner of the graph, is at 0, -3. Now there is a way to find that up here in your equation. We'll take it off the graph, and in class we'll talk about how to find it off the equation. The shifts, it went down 3, and it shrank or shrinks 1/2. Okay, next page. When the 2's on the outside and it's a positive, well, you think about how it would shift from previous graphs. What's the pattern? On the outside of the absolutes, it seems to shift it up or down. That would be up 2. Now, with the negative out front, we know from the very first graph that we did that caused a reflection. It flips it, in other words, upside down to look like that. The other shift was up 2. So now we draw it down 1 over 1 to get the correct slope, or just draw the diagonal. And that's how it's going to look. We can see that our vertex is 0, 2. Please see if you can figure out how you could get this out of the equation. That's what I'm going to be asking you in class. So the next one, we have the number inside the absolute, not afterwards. So we know it's not shifting up and down when it's inside the absolute. Look back in your notes. We're on page 9 but we did some of those transformations inside the absolute on page 7. Take a look and see what direction it moved. If you don't know, then start plugging in points. If you look at page 7, you'll see that a negative on the inside caused it to move right that many units. So it's going to go right 1 unit. In addition, it's got the stretch factor out here. It's going to change our slope to 2/1. So it's a stretch of 2. So we go to the right. Here's our parent graph, graphed like that. We go to the right 1, put our new vertex, and now instead of going up 1/1, we go up 2/1, and we make a skinny, real skinny V shape. I went a little bit past my vertex there. My vertex is at 1, 0. Okay, next graph. Continue to see if you can find how we can find the vertex by just looking at the equation. For now, we're just going to get it off the graph. So, outside the equation, that pushes us down 4. Inside of the bracket, the absolute, that positive 2 will make us go left 2. So we go left 2, down 4, and now we graph our parent function. The slope isn't affected. So we draw our straight lines there. And there's our transformations. These are much quicker to graph this way. Now we look at where our vertex is. It's at -2, -4. How could you get that from the equation? That's my question for when we open class. That concludes our transformations. I want to make sure that you've watched all 3 parts. All 3 were assigned. Thank you.